Hello everyone. Today, I'll be explaining the project of predicting using supervised machine learning algorithm. So here I'm using linear regression model, and it's a very simple model which we can use in almost all the projects which are linear in nature. Okay, so the first step which we should do is import the required libraries. So here I'm importing these libraries, that is NumPy, Pandas, Matplotlib. Then from the scikit-learn module we can import the train test split, then linear regression matrices, and you can give this percentage matplotlib inline so that the graph comes inline. Okay, and the next step which we should do after importing the modules is we have to read the file, that is we have to read the sample data which has been given. So that I'll be doing using the pandas module, that is pd.read.csv. It's a csv file which I have saved it in my system. So I have read it and stored it into a variable called data, and I'm looking the first 5 rows of this data dot, and that can be done using this data dot head command. So the head means it gives the first 5 rows of the data, and if you want the last 5 rows you can give data dot tail. Then if you want the first 10 rows you can give data dot head bracket inside 10. Okay, after that, what we should do is we should visualize the data. We should do the exploratory data analysis. We have to analyze the data. So I'll be analyzing the data. So first I'll be plotting a graph between the roll number and the scores of different students. So here I have plotted it using these commands that can be seen here. Okay, so we'll analyze this graph. So this red line is the scores with respect to roll number. So this roll number, there is no roll number 0, but in the data it is given like that, so we can assume it as the first student. So roll number 0 has 20 marks, then 1 has like between 40 and 50. So from this graph it's just a visual representation of this table. Okay, and the next graph which I have plotted is the important graph which helps us understand which type of algorithm we should use. Here I have plotted the graph between the time and the scores. These are the two different columns, that is two different attributes which are in our data. That is the time, that is the hours, and the scores. So this hours and the scores are the things which depends the output of the student. Okay. Yeah. So this is that graph which shows variation of scores with hours. So if a student studies 1 hour a day, then he'll get 20 marks. If he studies like 2 hours, here approximately 2 hours, he gets between 20 and 30. Like that, if a student studies 9 hours a day, like 8 to 9 hours a day, maximum marks is above 90. So from this we can understand that the graph is following a linear pattern. See, it's a linear line. It's a line-like thing. So we understand that we can use a linear model. So I'm using linear regression here. Okay. Next, after we get to know what type of model we should use, and since this data has no null values or nothing, and no empty rows, I need not do anything else further. If we have any null values, then we should take care of that. Okay, so after this understanding what type of model we should use, we can move to the model creation. So that is the next step, that is creating the object of model class. So as I told you, I'm using linear regression model. So I'm just creating an object of that model, linear regression, and I'm naming it as model. Okay. Yeah. Next is splitting the dataset into attributes and labels. Attributes and labels means attributes are the columns which we have the values for, and labels are the columns which the prediction has to be done. So we have to split the table into attributes and labels so that we can apply those values into our model. So the thing about linear regression model is that you need the attributes x and the labels y as a two-dimensional array. So for that, we can use the ilog method, which creates a two-dimensional array, ilog.values, and this ilog method takes in two arguments, that is the number of rows, comma, number of columns. So here I'm taking all rows and all columns except the last one, because the last one is our label, that is the scores which we have to predict. And next is y, that is data.ilog of all rows, comma, all columns excluding the zeroth and the first column, that is one column, that is the meaning. Dot values means if you just write data.ilog, then you will not get a two-dimensional array. If you write dot values, then you will get a 2D array. Okay. After that, I'm just showing you the two-dimensional array which is formed after the operation. After that, we have to divide our dataset into training and testing dataset, like subdivisions. So x train, x test, y train, y test. We are using train test split module, that is x comma y. That is just the arrays which we created, the 2D arrays. Okay. Next is we have to train the model. Once we have the training and testing dataset, we have to train the model. So the model is already the linear regression, that model dot fit. This is the command which we give to train the model of x train comma y train. That is the train. We are training the model with the training dataset. Okay. Next, we after training, we are just visualizing our graph again. So I have just plotted the training. After training, I have just plotted the linear regression line also. So for that, the command you have a y is equal to mx plus c is our straight line equation. So in that, m is the slope. So model dot coefficient is used for finding the slope, and model dot intercept is used for finding the intercept, that is the c, y intercept. Next, we are plotting the graph using plt dot scatter of x comma y, and yeah, that's it. So we get a line, plt dot scatter. We are plotting the scatter plot, that is our blue dots, and this plot is our line. Next, I'm just printing the testing dataset. Okay, so that is also a two-dimensional array because the linear regression gives a two-dimensional array. Next, we can make predictions using our trained model. For that, we am using ypred variable is equal to model dot predict. This is the command which we use of test x test. That is our, we are testing the model, right? So we are giving the testing data. So model dot predict of x test, and we can look at the values which are given in the predicted variable. So we got 86.53. These are the values corresponding to the testing data set which we have taken. See, this is the testing data, 8.5, 2.5. So if a student studies for 8.5 hours, then he'll get 86.53 percentage marks. It's like that. Okay. So next, we are just comparing our actual value with our predicted value. So if a student, like the first roll number, let us see how much time he studied. So the first roll number 0 has studied 2.5 hours. Okay, so the actual value and predicted value are being compared. Actually, the error, there is a reasonable error which is happening here. So for the actual value, it is actually 75 marks which we will get, but the predicted value is showing 86. So there is a little bit of error in this. So that is due to this linear model. We can use another model so that it becomes more accurate. Okay. So next is predicting with random values. So we predicted with the values which is already there in the table, but which was not used for training. Next, we can predict with another value which is not in the table. So I'm just predicting for 9.25 hours. If a student studies for 9.25 hours, how much mark will he get? So I'm just again training, like creating a prediction model dot predict of hours. I'm just predicting the value, how much marks will he get if he studies 9.25 hours. So here it's the prediction has come, 93.9201 percentage marks he will get if a student, he or she will get if a student studies for 9.25 hours according to our model. Next, we are just calculating the accuracy of our model. For calculating the accuracy, we just look into the errors. That is our mean absolute error, mean square error. There are so many errors. Here I just calculated the two of these. So here mean absolute error can be calculated from that metrics module which we just imported, matrices dot mean absolute error, and we get it as 5.861. And our mean square error, we get it as 43.374. Okay, so that's our mark prediction using our dataset, you supervised machine learning model. So this is just a linear regression tutorial. Thank you.